All right. Hey, guys. So this is the, again, Unit 3 test, and this is implicit differentiation. They give you a function which looks to be just like a mix of x's and y's, and they want you to find um, the derivative, okay, of or dy dx, the rate of change of y in with respect to x. Okay, and so you have to immediately identify that this is a implicit differentiation, or you know you're most likely going to solve this the easiest way using implicit differentiation. So you take d dx of both sides, or the derivative with respect to x. Okay, and that d dx distributes over top of this polynomial here. So notice my d dx here, here, and here. Now, each one of these is its own little mini derivative, okay? But the derivative with respect to x to y squared is 2y. And then remember that this is the chain rule because y is a function of x. And so when you take a derivative of it, you write the derivative of y with respect to x would go here because remember, you basically have a function with inside of a power right here. That function is a function y with respect to x. And so we're going to do power rule, chain rule, okay? And you end up with a dy dx. Here we have basically the product rule. So you've got x times a function with respect to x, okay? And so my product rule tells me I'll take the derivative of the first, so the derivative of x is 1, and don't take the derivative of that, so I just replace my function. And then plus, I'll not take the derivative of this, and now I'll take the derivative of the function. The derivative of function y with respect to x is just dy dx, okay? So the derivative of y with respect to x is dy dx, okay? And there's no chain rule here because y is just sitting all by itself. It's not like it's y squared or something. If it were y squared, I would end up having a 2y here and also the dy dx, okay? That's if there was a y squared here. And now this one's pretty easy. The derivative of x squared is simply 2x. And then you don't write the dx dx here. I mean, you can, dx dx, you can write it right there, but that's really just 1. And then the derivative with respect to x of 1 is 0, right? Because 1 doesn't change as x changes, because 1 just stays the number 1. Anyway, now that you've got all that situated, I'm going to go ahead and remove my brackets. Oh my, look at that. I forgot my negative sign. Here we go. There's a bit of a mistake here. Look at that. Notice this negative sign was supposed to distribute in. Okay, very nice. So that was supposed to be a negative here as well. Okay. And then I guess we would have needed a negative here as well. And finally, a negative here as well. It's a good thing I missed that, or I didn't miss that, or whatever. It's a good thing I found. Anyway, now that negative sign distributes in. Now, what you're supposed to do here is notice you got both of these dy's over here. You pass this y over, so therefore that y becomes this negative y. It's passed over to be a positive y, and this 2x is a negative 2x. Now, coming up over here, I factor out the dy dx. Notice there's a dy dx. I factor it out, leaving this whole binomial, and that entire binomial now gets divided underneath, and this is the derivative of y with respect to x there, and as it has y's in there. And in the end, what you can do, if you really want to, is you can solve for y up in this thing and put it in here. So you have only x's in here, but honestly, it's not necessary. We can just leave it like this because there's nothing wrong with this derivative. This is okay, especially according to the AP exam. If you're taking the AP exam, they're okay with that. All right. So anyway, there's that one. Implicit differentiation.